Hello and welcome back to Nature of Code in Rust and GGEZ. In this video, we're going to be going over exercise 2.4. This is where we're going to be creating like a pocket or a zone of friction that our mover is going to move through and then have friction applied to it. So it's not going to be a constant friction all the time like the last example. So what I'm thinking of doing for this one is have a long horizontal arena screen where we have the ball move through some colored zones, maybe like red for slowing down and green for speeding up. Although I think some people are maybe red green colorblind. Maybe we can do like red and blue, um, something like that, and then they'll slow down and speed up correspondingly. So um, before I get into that, I do want to show a big change that I made to GitHub here for Nature of Code. Where's my mouse? I think my mouse battery's died. Hold on, give me 1 second. All right, I'm back, got a plugged in mouse, and let's go. So where are we going? We're going to look through Nature of Code in Rust. So I made a bunch of changes here. I have now all of our, let's see, did that not, I've got to push all of these up. Hold on, let me push these up really quickly. So if I look through this, I've got tags. Now I've created them on my local system. I'm going to push all of these tags up to the website so then you can see the code at that time. So instead of a folder structure, now all of our code is just going to be straight up in the base with tags for each version. And we're going to do the exact same thing for exercise 2.4. So let's go ahead and get started. I'm going to open up my code here. If we run what I have right now, I've done a little bit of setup for this. We have a long horizontal window. My plan is to create our mover object here and have it move across the screen. And then we're going to create the zones that apply friction right here in the middle. So let's go ahead and set up mover. Now, in the process of me setting all of this up, I accidentally deleted a bunch of like things in a vector and a mover, so I had to recreate them. So there's some minor changes here, but let's take a look at mover. The big change is I do have this location asmint 0.2, so our vector class has now an asmint 0.2 method on it. I have like a reset method that just zeroes things out, things like that. And we can add new stuff as we need it. Okay, so first off, let's create a new mover and set things up for ourselves. So in main state, we're gonna have our mover, which is a mover. I don't see mover in here. Oh, I need to mod mover. That's right. Then we can pull it in. Import mover. Okay, let's create a new one. Okay, so mover is taking a new location. We're going to put it in the exact center, which means we need context so we can get the width and height. Okay, so this is going to be a vector2 new for the x. I want this to be just to the just starting to the left of the screen, so we can just maybe put this at 0, 0. And then for the y, I want this halfway down, so that's going to be height divided by 2. And then do we need anything else in here? Oh yes, the radius. Whatever the radius of this is going to be, let's make this something nice and large. Let's do like 25. 0. And then we'll save the mover away. I'm not going to do any updates. We just want to see the mover, display it onto the screen to begin with. Now I have made a little bit of a change to how the draw system works here. We're going to create a mesh builder in GGEZ here. So mute mesh builder. And then for each object that we want to draw out, we're going to hand it the mesh builder and it's going to draw it. So I can at this point do self dot mover, not mouse, mover dot draw and hand it a mutable reference to this mesh builder. And then we can build the mesh and draw it out. And so what this means is, oh, I need to forget, question mark. If we go into our mover draw method here, we can see that it takes in a mesh builder and then it just applies a circle to it. So this way, every single frame, our movers, so if you have multiple of them, are going to add, where they are to this mesh. They're going to draw themselves essentially. So then if we go ahead, let's see, this width, we don't need that. And I think, we have 8 warnings. Most of them are in here and like, update. Yeah, we're not using a lot of those. That should be fine for right now. We should be able to see our mover on the screen. There it is on the left. Okay, so if we want to give it an initial acceleration to get it moving to the right, we're going to do that over here in the main lib. So we're going to make the mover mutable. And we're going to have mover.apply a force. We're going to have this moving to the right. Let's give it like a decent speed. So maybe something like 3.0. No up and down. We just want this moving purely to the right. And I think that works for this. In update, we need to now tell the mover to update. So self.mover.update. And let's go ahead and see how this affects things. There we go. Now our mover moves across the screen. Now, when it reaches the end of the screen, nothing happens. I did take the liberty of updating the check edges function. It just checks to see if we're off the right-hand side of the screen, and if we are, reset ourselves back to the left side. So in our update function, we can just call that. We do need the screen width for this. Now, while we're here, to get a consistent movement, we're going to want to also make sure we're running at a 60 frames per second, at least for the updates. So let's go ahead and just sort of set that up too. So while we have the timer, check the update time. We're going for 60 frames per second. And then we need our width and height. And that will allow us to get our screen width, which is this width. So if we run this again, now our ball should start off, everything should be good. It hits the right-hand side and then should reset over to the left. And there we go. So we have just sort of an infinite moving to the right. It never loses any velocity, but also never gains any either. So let's go ahead and change that. We're going to want to create a zone that has some kind of friction applied to it. So I was thinking that the best way that we can think about this is probably an actual, like a new struct. So I'm going to create in here a zone. RS. And in our main library, we're going to mod it. So what do we need here? I'm thinking we're going to have an area that covers probably from the top to the bottom, and then a certain area to the left and right. So it's basically going to be a rectangle. So if we want a rectangle, we're going to have an X and a Y, width, and a height. Then I want it to have like a color so we can actually see that it's being applied. So a color. And let's see. And we're going to need a coefficient of friction. Which is going to be an F32. And I think that's all we need for this. Let's go ahead and create our constructor for this. All right, so we're going to take in an X, which is 2. The color, which is a color, and the coefficient of friction, which is an F32, and we're going to return a new self. All right, that should make this happy. So back into the main library. Now I'm going to want multiple of these zones. So I'm just going to go ahead and set us up as a vector of these. We're going to have 2 for this example, but using this, if you're following along, you want to do your own, you can just add as many zones as you want, essentially. We're going to have zones, and this is going to be a vec of zone. So let's create those here. So we're going to have zones. We're going to use the vec macro, and then we're going to put the first zone in here. So zone, new, and then this is, I need to pull you in. Okay, what's that first thing? So the X position. Let's just go like 300 from the left. And then the Y, well, that's going to be 0, 0. Width, we want, let's make this like 500. And then the height, we want this to be the entire height. Color. We want you to be, let's make this red so it slows things down. So red, 1.0, the rest are zeros. And then for alpha, I don't want this to be solid red, maybe like 0.3 for a very pale red. And then the coefficient of friction, let's do 0.01, for example. And that gives us a new zone. Then we can add in our zones here. And well, I mean, that's happy for that, but we need to actually draw these out. So for zone, we can have it know how to draw itself out. We're not going to have to create anything here. Oh, but we are going to have to take in a mesh builder. A mutable reference to a mesh builder. So once we have that, we want to apply a rectangle to it. In order to apply a rectangle to it, we have to have a rect. So I'm actually going to, now I don't want to like do something where it's like a 2, maybe a 2 rect would be good. I'm gonna have a private function here, to rect, maybe as rect. Not sure exactly the right like name to do this. We're gonna create a rect from a reference of this. So, and it's gonna be a GGEZ rect. All right, so this is going to be rect, new, then we give it just the X, so self.x, self.y, self.width, self.height. By breaking this out into a different function, it's just going to be a little bit easier for me to like, just do this mesh builder in one go. So do a mesh builder, I'm gonna add a rectangle, draw mode, we're gonna fill. For the bounds, that's gonna be the self as rect, and for the color, self.color. And that's it. That's going to apply the rectangle to there. So then back into the main library, we want to draw this behind the mover, so it needs to come first. We're going to loop through all of these zones. So for zone in, a reference to self.zones. We're just going to call zone draw and hand it in a mutable reference to the mesh builder. So if we run this now, there is our zone for slowing down. So let's say we want to actually stop in the middle here. That might be nice. Let's, because I could see it being annoying if like I don't stop in exactly the middle. It just sort of I think looks a little bit nicer if we stop in the middle too. Let's figure out how do we want to do this. So if we have, so here's our width. Let's like find the middle spot. Middle spot is going to be the width divided in half. So if we want this to be like a 500 length, we can do width divided by 2 minus 500. And then this is going to be 500 to get to the middle. So if we run you, that looks a lot better. Okay, so what if I want to apply the actual friction force to the mover? I'm thinking that the zone should be in charge of this. The zone knows what movers are going through it and then properly applies the friction to each of them. So what that means is in update, we're going to loop through all the zones and then apply friction to them. So we're going to have another function here. Apply friction to mover. And we do need the mover, which is going to be a mutable reference to a mover. And then we're not going to return anything. I don't think we need to here. So to create that friction, we need to get a copy of the velocity. So let friction equals mover dot velocity. Okay, so we have that. Once we have that, we want to reverse the velocity. So it's going to be friction dot reverse. I did make a reverse function. If we go and take a look at it, it's just basically times equaling each of the arms by -1. And at this point in time, I think I have mul assign. So I should actually just be able to do self times equals -1.0. That should also work. Are you... Oh, do I not have it? I have mul. Oh, I do have mul assign F32 for vector 2. Why don't you let me do that? Oh, I need to dereference self. That's why, because it's a mutable reference. Okay, so back to zone. So we've reversed it here. We then want to normalize it. Once we've normalized it, we want to multiply it by that coefficient of friction. So we can just times equals self dot coefficient of friction. And then we want to apply this force to the mover. So let's go ahead and run this. So in update, so we have to do the same thing here. We have to loop through all of our zones here. So for zone in a reference to self.zones, apply friction to mover, and it's going to be a mutable reference to self.mover. So if we run this now, it's just constantly moving it. So we need to make sure that we're doing this only if the ball is within the zone. The reason why I think that the ball wasn't moving is I think that our velocity became not a number because it's zeroed out. So we should probably handle that too. So in zone, apply friction to mover. If we get this friction and it's zeroed, so we can get like the magnitude of it and check to see if that's 0, then we need to just like early exit. So if friction dot magnitude is equal to 0.0, then we just need to get out. Otherwise we can, continue on. Okay, so we've got that. The other thing is we also need to make sure that we're within there. So if mover dot location dot x, so if you're to the right of self dot x and mover and something that might be helpful is maybe we can make this a guard class. The way I'm writing this right now, we're going to have to indent everything for more. So what if I do, if mover.location.x is less than self.x, or mover.location.x is greater than self.x plus self.width, then we also want to return. And then I can maybe add this. We can grab this and we can add this here too. So, or if this is 0, and then it's a single guard if statement. So we only have to have one return here. Okay, so there's our guard. We grab our friction out and we check it. And then we do the rest of it. So let's see if that works. So we have our ball and moves forward, and it definitely slows down by the time it actually doesn't even make it through this entire it doesn't make it through the zone, which is potentially a little unfortunate. Let's make sure that we have enough speed for our ball going through. So let's increase that. So we have apply force. Let's make you like a 4 and see if you get through, because I'm thinking we're going to create another zone, because the second part of this exercise is to create, there we go. It slows down there. Maybe it didn't slow quite enough. Let's do like 3.5. We want to create a pocket of the opposite of friction, something that when it goes into it, it speeds up. Okay, so it barely reaches in here. So I want another zone to increase its velocity. So I think we can maybe play with this. Let's do like something like 3.2, just to see if it barely reaches the end. And then we're going to create something with opposite of friction. There, perfect. It barely reaches the end. So here in our new, we're going to create another zone right here. Okay, so for our x, I want this to start in the middle. So we're going to do width divided by 2. For the y, we want this to start at 0.0. For the width, we're going to do 500, so it's exactly the same width. We're going to make the height the same too. Color, let's make this no red. Green, there's red-green color blindness. So let's have no green. Oh, you know what? Maybe we can have like a little tiny bit of green, like 0.3 green, and then 1.0 blue, like a lot of blue in there. Maybe you can do 0.7. So altogether it makes sort of a 1, and then we'll do a 0.3 alpha for this color too. And then the coefficient of friction, I want this to be exactly the opposite of what we had above, so it speeds up. This is going to be a negative 0.1. So just by doing this, I believe we've finished the exercise, but let's go ahead and prove it. We have our mover, it comes in, it slows down from our friction, it reaches the blue zone, and then it takes off and speeds back up, reaching the exact same velocity that it had before, and then just wraps around to continue it again. And so that's our exercise 2.4, which is pockets of zones that have friction in them, including the opposite of friction. Thank you so much for watching, and I will see you in the next video. Bye.